Hi, welcome to SS 8.2. This is all about surface area. Surface area has to be done on 3D objects. It can't be done on flat objects. It has to be 3D, so there's many different surfaces. And part of this outcome is that you can look at your 3D object from different views, maybe from the top or the side or the bottom, and you're supposed to be able to sketch them and come up with strategies and formula for solving the surface area, and analyze the effective orientation. So does it matter if you turn it or look at it from a different angle, and solving problems with that. So surface area, you might be talking about finding the cost of materials. If you were going to put siding on your house, that has to do with surface area. If you're finding the amount of material that it takes to make a tent, that's all surface area. Okay, so let's go to our next slide here. This is a fairly simple example. This is just a rectangular prism. And so they've given the measurements 3 by 2 by 6. And one of the most common misconceptions in surface area is that kids will go surface area equals 3 times 2 times 6. And they just take those three values and stuff them together in a formula and call it a day. But technically what you just found was not surface area, it's volume. Right? Volume is length times height times width. So that's probably the most common misconception, is that students get volume and surface area mixed up. So let me see if I can find the eraser. Ah, look at that. I did. Okay, so surface area, you have to think of it in separate steps. So what I would do is we have this front surface, which is this guy, and it is 3 by 6. So surface area equals, there are 2 of those sides, right? There's another one right here. There are 2 of those, so we do 2 times 3 times 6. And then we have the top, which is this guy, which is 2 by 3, and there are 2 of those. So we have 2 times 2 times 3. Okay. Then we have this side, which is this guy, and that is 6 by 2. And of course there are 2 of them. Okay. And so surface area is just a matter of adding up all of those different values. So let's figure out the red guys. 2 times 3 is 6 times 6 is 36. The green guys, 2 times 2 is 4 times 3 is 12. And the blue guys, 2 times 2 is 4 times 6 is 24. And then you can add all those together. So 36 and 36, we have, I believe, 74. And you would give your units. This is just area, so it's centimeters squared. And that's another misconception, is, just because you're finding the shape of 3 different parts, it's not a cubed unit, it's just squared at the end. This slide shows that any 3D object can be looked at from different views. So these are all 1 centimeter cubes on this green shape up here. And so if we were looking at it from the top, we would see this, 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 and this, which would look like those 8 blocks right there. If we were standing in front of it looking at this view, we would see that. If we were standing on the left side, we would see those 3 with 2 rows. And if we were standing on the right side, we would see this guy. So these are sort of like nets drawn to show what each view looks like. And what they've done down here to find the surface area is they've just counted up those blocks, saying there were 8 on the top and there were 9 on the front and 9 on the back, and they've added them all together and come up with 46. You can find surface area on any 3D object, so this one is a triangle. And they've set it up just the same way that I did with the other example. They're looking at each surface specifically. This one doesn't have it drawn out in a net like the other one did. This is just the shape, so we have to sort of visualize what each net looks like. Okay, so they've said the triangle area is 2, so the triangle is this guy here, and there's 2 of them, and they are 1/2 base times height, so 1/2 of 4 times 3. But because there's 2 of them, technically we don't need this part, because 1/2 times 2, everything cancels out and you're just left with 1. So when you're finding the surface area of a triangular prism, you end up with this 2 halves, which makes a 1. So really what you're looking at is 4 times 3 is 12. Okay, now the rectangle area 1 of the floor. So the floor is 4 by 8. Okay. The rectangle area 2 is the left wall, which is this guy, and that is 3 by 8. And the rectangle area 3, the slope on the front, I'm getting pretty colorful here. Let's go yellow. So this slope on the front, which is 8 by 5. Okay, so we have the 2 end pieces, which is the triangle. We have the floor. We have the left wall. And we have the slope on the top there. And then you would add all those things together, and that would be your total surface area. I'm not going to add right now, but you can if you really love to. Okay, the area, lateral surface area, lateral just means the sides. And if you think about a can of soup, what they want with lateral surface area is the label. Okay. Now this net that they've drawn here shows that if you took the top of the soup can and unrolled it, that is the length of your rectangle. So on your soup can, have a look down at Mr. Campbell's down there. If I cut right here and cut this label off, the distance around the top of the can is actually the distance of my label, right? There's my label. So the distance around a circle is called the circumference. And the formula for circumference is pi d. So technically this length is pi d. The height of the soup can, they should give you that. So if they're saying that the radius is 5 on the soup label and that the height is 6, so they've given a radius of 5, then we're doing pi d, and we're also doing pi d times 6, because we want to multiply by the height. So a couple of different things in here. They haven't given you the diameter, they've given you the radius. So you need to know the difference between a diameter and a radius, which is actually, if we did pi times 2 times radius, we would get the same answer. So 3.14 times 10 times 6 would give you our surface area of Mr. Soup Can.